So today we're going to take a look at the second part of the review. So we have three parts here, so we can start it as f of x equals, well, what is this first part here? Well, that's at -2. So that first one is -2. Well, the second one is a parabola. So we have x squared. And this third one we have a line. So let's see, what's the equation of that line? So down 2 over 1, down 2 over 1. So if it kept going, it would be 2x minus 3. Now we have to put the domains. So let's see. It changes here, and it changes here. So that's at 1 and -3. So the -2 is where x is less than -3. The parabola is in between -3 and 1, so we start with -3 less than or equal to, because it's closed in, x less than or equal to 1. And then the line, well, that's where it is greater than or equal to 1. And so I'm going to go here and I'm going to change this one just to a less than, because it is an open circle. So the next one, we're asked to graph it. So x plus 4, so our y-intercept is 4, up 1 over 1. So I could just dash this in across the entire graph. The next one is -2. So we got -2. So there's this one right here. And then the last one, we have 1/3 x plus 6. So 1, 2, 3, 4, 5, 6. We go down 1 over 3, down 1 over 3, down 1 over 3. So we have our line. So now for our domains. It changes at -4, so when it's less than -4. So on this purple one, because purple was our top one, to -4, 1, 2, 1, 2, 3, 4. And we want it when it's less. So that's going to be our line going that way. So now I can go and I can erase all these dots. When do we want the green one? Well, in between -4, 1, 2, 3, 4, and -3. But those should both be open circles. So between -4 and -3, we have open. So I can go now, and that's all we want this one, so we can erase those. And I think I got this purple one off by 1. So there we go. And then this last one, we want it when it's greater than -3. So we would go here. Here's -3. Put an open circle, and we want it when it is greater. And then we can go and erase this dot. The other way, again, that you can make it is you can make this table. So we have x plus 4. So at -4, plug that in, we get 0. And we need values that are less than that. So at -5, -5 plus 4 is -1. And I could go here. This was a pretty bad line there. I should probably line this one up a little bit better here. There we go. All right, and so then this green one here, we have 2 if it's between -4 and 3. So -4 and 3. And I just realized I did -2. So I'm going to go back up here and move it up there to +2. And then the last one we did was this blue one. So we have -1/3 x plus 6. So we have x and y, and we're going to start at -3. So if we plug -3 in there, we end up with 7. we plug 0, we end up with 6, and then we could connect those lines. So on this back page, we're going to take a look at the end behavior. So we look for the highest power and that leading coefficient. So it's odd, so it's a squiggly, and it's negative. So it's that squiggly going down. So as x goes to infinity, y is going down. And as x goes towards negative infinity, y is going up. So describe what happens to f of x given negative 2 times 1/3 x. Think about what happens to the y values and what happens to the x values. So it's going to be our y values, since that negative 2 is on the outside, it's going to be y times negative 2. And then that x is next to the 1/3, but x is always the reciprocal, so it's going to be x times 3. So if a point on f of x was negative 2, 4, what would the new transformation be? Well, x times 3, so that's going to be negative 6. Y times negative 2, so that'll be negative 8. In the last one here, describe the translation of g of x given by g of x plus 2 minus 3 and draw it. Well, plus 2 moves it to the left 2, negative 3 moves it down 3. So if we take each of these to the left 2, down 3, 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 we would have it.